Today we're talking about competing function model validation. What this means is it's another way we're going to look at of trying to decide which function fits best, right? So we've already talked about this a little bit. One thing that we can do sometimes is just look at our functions, right? This is whenever we did that, kind of like when we did that project, right? And you guys had all the different projects. We had the Hershey Kisses and we had the dominoes and our hand length and height, right? And as we looked at it, there were several different things we looked at to decide if something was going to be, at the time we were looking at like linear, quadratic, and cubic. We didn't have any exponential at that time, but we can add in exponential here, right? Some of it may just be looking at your data and using some common sense, right? For example, with handspans, we decided to go linear because even though cubic fit better according to our R squared value, it really shot up crazy and did things you wouldn't expect it to do. Linear, you are going to have an approximately constant rate of change. It might not be exactly constant, but approximately constant. One example that was on one of your tests was the number of people in an elevator and the weight of that elevator car, right? Each person you add is going to add a weight to that elevator. It's not every person's going to weigh the same, but it's going to be approximately linear, right? There needs to be no clear concavity for this, right? So it shouldn't be clearly concave up or concave down. Quadratics are going to have an increasing or decreasing rate of change. So you'll see that maybe you go up by 4, and then you go up by 8, and then you go up by 12, right? And it's going to have a U-shaped pattern. So if you see anything that might have like a maximum or a minimum, a lot of times quadratic's going to work well for that. For exponentials, your output values are roughly proportional. So we looked at this the other day about like if we can look at our rates of change, they're increasing by multiplication, right? So there's a number we can multiply by each time. And you should see either growth that starts slow and grows rapidly, or it could be decay where it starts fast and then sort of evens out for that. All those things that we've already looked at can kind of indicate where we should look at this type of regression. But sometimes it's not terribly clear. So one thing that we're going to look at to help us today is residuals. And we already talked about residuals just a little bit whenever we were doing those regressions in Unit 1. And a residual is going to be the actual output value minus the predicted output value. Predicted is the one that comes from your equation, right? So actual minus predicted. So for example 1 here, we have the line P of t equals 12.4t plus 12 can be used to predict the pay of a waitress who works t hours. Use the waitress here because does a waitress make the same amount of money all the time? They do not, because they are paid on tips, so they might have a really good night on tips or a bad night, right? If you work at Chick-fil-A, it doesn't matter, how many customers they had that night or how well you did. It's just a set rate. So this is going to be a prediction, but not the exact amount for waitresses. Last night, Jessica worked 5 hours and made $82. What is the residual for Jessica's pay? So first of all, residual is going to be actual minus predicted. So residual is actual minus predicted. What was Jessica's actual pay? 82, right? How do we find her predicted pay? Plug 5 into t. So if we do that, P of 5 is going to be 12.4 times 5 plus 12. Somebody that's got their calculator out, what is that? Is it exactly 74? Okay. So we would subtract 74, and we would get 8. Okay, what does that mean for Jessica?
She made more than we.
Right, she made, so Jessica made $8 more than predicted. So she had a relatively good night compared to this here. Okay, so that's a residual, actual minus predicted. Some of the questions you get may just ask you for a residual. All right. Now, residuals, every point that you have when you do a regression has a residual. And we're going to look at an example for this. And we're going to look at it several different ways. So, Paul is on a diet. He has been tracking his weight each week so far. The results are shown in the table to the right. Okay, so it's given here. We're going to graph this here just to see what it looks like. Here, I put the closest thing I had to the squiggle that means you've skipped numbers was a lightning bolt in my options right here. Usually that's going to be drawn like this right here on the y-axis there to show we skipped from 0 up to 195 because we don't really need that part of the graph, right? So at 0, we've got 215. 1, we've got 210. Hold on a second. Does your next table look like this? Oh, I changed the numbers and I didn't change them over here. Hold on. Let's change these numbers because it's going to mess us up. Sorry. You guys are my guinea pigs on this. Why won't it go? There we go. Okay. We want these numbers here because it won't work right if we use. All right. In this right here, change those numbers for me. Sorry about that. Okay. So we'll change where we got 217. 210, 204, 200, and 198. Okay. Just first glance looking at this, what do you think we have here? Linear, quadratic, exponential. Okay. An exponential decay, possibly. Quadratic might not be bad. Now, quadratic, actually, it's like any diet I go on, this is going to happen to Paul too, right? Goes down to quadratic. If it goes down, what's going to happen to the quadratic? It's going to go back up. That does happen on our diets sometimes. But quadratic could be possible. Is linear going to be far off? Not way far off, but it does look like there's a little bit of concavity here. So I'm thinking maybe linear might not be as good. So one thing we can examine for this is called a residual plot. So let's look at how to make a residual plot. So we are going to do all three, linear, quadratic, and exponential. So the first thing we are going to do is go to our calculator and put in this data and get a linear model. So we should be getting pretty good at this by now. We can go to Stat, Edit, clear out anything that you have there, and type your data All right. So, oh, I accidentally went. All right, let's do our linear regression. So, stat, calc, number 4, linear regression. Let's store this in Y1. So, go down here, store regression equation, alpha trace, Y1. And let's write our equation up here. We would get y equals negative 4.8x plus 215.4. Now we would just plug the numbers in for x. And remember, there is a pretty quick way to do this. We can just do alpha trace y1 of 0, and it'll plug that number in for us. I guess we should have known that was 215.4. So 215.4, and then we can do the same thing of 1. Actually, hold on. I don't even need to do this. What's a quicker way? This will work for sure. I just stored this in Y1, right? Where could I go where it'd give me all of these at once? Table. Let's go to table. Let's do second graph. That'll take us to the table. I have 5,000 in my Y2. Let me clear that out. That's from another problem. Table gives me all of these at once. That'll be even faster. 210.6. You probably did not store it. Did you do second graph, or did you go to... Yours is still on ask. No, you don't have... Hit Y equals. Yeah, I think your Y equals is empty. Yeah, it's empty. You did not store it. I don't know why it didn't store. Try your regression again. I think yours is also on ask too, but
Mine's on ask, but I just typed in values.
yeah, you can definitely do that. And I'll remind you how to fix it back to the other way if you want it. Okay, now type in like 0, 1, 2, 3. See if you get something. Is it stuff coming up? Hit Y equals for me. Okay, it's there. All right, so try this. If yours looks weird, do second window, which takes you to table setup. And then you want this to start at 0. You want it to go up by 1. And you want that independent to be on auto, not on ask. And then if you go back to the table, second graph. Is it working now? Okay, good. 201, and we got 196.2. Okay, everybody okay here? All right, now, how do we find the residual? Subtract, right? So we got 217 minus 215.4, so it's 1.6. Here we'll get negative 0.6. Here we'll get negative 1.8. Here we'll get negative 1. And here we will get positive 1.8. So what I want us to graph here, I want us to graph a residual plot. So a residual plot takes the original x as your x-axis, and it uses the residual on your y, right? So right here, this is weeks. On the x-axis, we could add in a 1 right there and a 3 if we want. And then the y-axis is your residual. Okay, if we graph these at 0, we got 1.6 right there. At 1, we have negative 0.6 about right here. 2, we have negative 1.8. It's about right here. 3 is negative 1. It's here. And 4 is 1.8. Now, one thing we're definitely looking for on a residual plot is if our model is good, our residuals should be small, right? So we shouldn't be that far away from the point. So if we see our residual plots have really big numbers over here, like if we're going up to 20 and negative 20, right? Depending on the situation, that tells us that these are not very good. Now, I don't have anything to compare this to yet because I haven't done the other two. So let's just wait on this. Oh gosh. Here, I'm gonna screenshot this because when I go to the next one, this is going to disappear and then we're not going to be able to compare them. And then let's do a new Word document. Put it here. All right, you guys will be able to look back because yours is on paper. But there we go. We've got that to look at. Okay, now we need to do the same thing for the next two types. Okay, so for the sake of time, let's have let's split you guys right here. So Tyler and Alyssa, you don't have to move, but you guys are over here. You guys are over here, and let's have you 5 right here. You guys do the quadratic. Okay, over here, I want you guys to skip to the slide for the exponential. Okay, and I am going to try to do them both real quick because maybe I'm faster than you, maybe I'm not. Let's see, so that we can see them on the screen. Do this for me too whenever you do yours. Don't erase what's in Y1 unless you've already done that, and that's okay. But put your quadratic in Y2, put your exponential in Y3. I know you're not going to do both of them, but that way we can look at all of them on the graph. Graph might be a little hard to do, that quadratic, but do the best you can. Alrighty. Let's see. Let's see if you guys are getting the same thing as me here for this. Let's pull this Word document. Okay, my quadratic people. Let's see if you guys get the same thing that I have. My model was 0.857x squared minus 8.229x plus 217.114. Okay, and then here are my predicted weights. My residuals were all very small for that. Negative 0.11, negative 0.26, negative 0.09, negative 0.14, and 0.09. Are you guys getting the same numbers there? Okay. All right. So it's a little hard to graph because everything's really close to that x-axis. So everything looks like it's almost on the x-axis. Now, when I see that happening on a residual, does that mean my model is good or bad? That's good, right? Because if I have small residuals, that means my line was not off from the actual values very much. So this residual plot looks better than the first residual plot because my values are a lot closer. Okay, let's look. And if you don't have time to get all of those down, that is okay for that there. Let's look at the exponential. So those of you that had the exponential, I got 215.455 times 0.977 to the, that should be an X that got cut off. Does that look right to you guys? Okay. And then, so are these numbers that I'm getting here looking like what you guys got also? And so this is what that graph looks like. Okay. So based on residual plots, which one of these do you guys think is the best model? I'd say quadratic for this. Because the exponential, I thought, like, whenever we were looking at it, Granger said he thought maybe it was exponential, and I thought maybe he was right on that, because it certainly sort of looks like it could be just an exponential decay sort of situation. But it looks more quadratic, really, when we look at those residuals. Huh? Yeah. See if I can, well, let me do this. I think I'll make it where they'll both show up on the same page. Let's see. There we go. Or at least almost both show up on the same page. There. So, certainly, one thing we're looking at for residual plots is we want those residuals to be smaller. If they are bigger, that tells that that does not match as good. There is also one other thing we want to see in a residual plot that happens on the quadratic model, but does not happen on the exponential or the linear model. If I look at this residual plot, what does it kind of look like I've got going on here? It's concave up. I got like a pattern, right? It looks like I was, it almost looks like a quadratic right there. And really, the same thing just about happened. I mean, the residual plots for the linear and the exponential look almost the same, right? We actually do not want that to happen whenever we're looking at residual plots. Because what that means, if we're looking at a residual plot, is that there's some sort of pattern to how we were off, right? Let's look over here at the calculator at the graphs. I've got all three of these in here. I think Y1 and Y3 are going to look a lot the same. But if I hit graph, well, actually, I want to do zoom, and I'm going to do number 9 for stat, so it'll give me the points that I want to see. My stat plot's not on, so that won't work. I got to turn my stat plot on because it is not on, because I'm not getting any dots here. So if I go to second Y equals, my stat plot's not on. If your stat plot's not on, it won't graph the points for you. So I'm going to go over here, turn that on. And then now I'm going to hit zoom and number 9. It doesn't even look like it's graphing that third line. That's just because the linear and the exponential are really, really close to each other there. But I can talk about this straight line like it's the linear or the exponential. I'm too low at first, right? And then I'm too high in the middle and then too low again. That's showing I've got some concavity to my graph that's not being shown here. So that's what's happening on this graph. So it seems like it might be a good thing to have a pattern on your residual plot, but it is not. Not on your residual plot. What you want to see is you want to see small residuals, and you want to see them scattered, random patterns, right? A few of them above, a few of them below. That's what we're seeing here, right? A few above, below. We don't have like a clear pattern. Okay, so this one, we would definitely say the quadratic is the best, which if I go over here and change my X max to like 10 is not good news for Paul, because look what happens. Falls apart. Now, I don't know that this is good for saying Paul's not going to be successful because of the way he's losing weight, right? We would just have to follow that. But currently, we're seeing this happen. And certainly we probably wouldn't see it like shoot back up forever, but sometimes you do see this in this case. So let's go back over here. We just got a couple more things to talk about. All right, so residual plots, what you're looking for on residual plots. Residual plots, if residual plots show no pattern the model may be appropriate for the data. Now, you have to use your judgment. Sometimes there might be a reason why you're choosing something other than just the residual plot, but this is another tool for us to use to see if it's good or not. And also, the lower the value, that shouldn't have anything right there. The lower, that should say the values for a residual plot, the better the model fits the data. However, even if you have low values, if you see a pattern, it still may not be the best. Right? So, if we look at that last question, it tells us several different models were developed for a data set. The residual plots for each model are shown below. Which model fits the data the best? Okay? All right, I'm hearing D. Why are you picking D, Tyler?
Because, for one, the values are the lowest, and there is no visible pattern.
Right. We would want to throw B and C out from the beginning because we've got like a swooping pattern there, right? So no matter what my Y values are, those are not that great because they have a pattern to them. A and D are both random, right? That you see random scattered data. So that is good for a residual plot. But what do you notice about your y-axis over here on A? Bigger, right? These are larger residuals, right? These go from like -2 to +2, whereas over here, we only go from -0.1 to like +0.2, right? We're in a much smaller range. So D would be our best answer for that. Okay. It's important to know this is for residual plots, right? If we're talking about the graph we graphed at first, we want to see a pattern in that. We want for the graph to be linear or exponential or whatever. But when we're talking about residual plots, we want no pattern. We want small residuals. Okay? All right, so you got a few minutes. The assignment tonight is a worksheet. Most of these are going to be multiple choice questions about residuals. You will not actually have to do a residual plot by hand for me on anything, but I think it's helpful to do just those few by hand and see what in the world it means, right? So as far as like being able to produce a residual plot, you probably won't have to be able to do that. You might have to be able to find me a single residual, like we did on that first example, but you're mostly going to need to be able to interpret what a residual plot means for that. So you got like 6 minutes. Let's try to do like a question or two before you go, and then we will